Hi everyone. In this video, I'm going to talk about one of the very fundamental and very important principle of IPv6, which is DAD, the duplicate address detection mechanism in IPv6. What I'll do is I'll explain you what duplicate address detection is, the concept behind it, how it works, and then in the very end, I'm going to give a live demo on GNS3, and I'll explain you about the packets involved in duplicate address detection, how the packet looks like, so that you can have you can develop a good understanding of how that works. So with that, let's get started. So let's say you have a PC, and this PC gets some IPv6 address. So you assign an IPv6 address. Now, there are different ways in which this PC can get IPv6 address. One is you can manually configure the IPv6 address. That's one way. It can also generate IPv6 address for itself, which we call as the SLAC, stateless address auto configuration. For example, it can generate, for example, if you would have heard of EUI64 address, this is one of the mechanisms to generate IPv6 address from the MAC address. Or some of the PCs, E1 deploys some other method, for example, where they generate some random numbers using which they form the IPv6 address for better security. Or your host can also get the IPv6 address from DHCP server. Okay. Now, whatever be the case, it does not matter how the host is getting IPv6 address, whether it is through this method or this method or this. As soon as it gets the IPv6 address, the very first thing it performs is called as DAD, the duplicate address detection, to ensure that the IP what it's going to use is unique in the network. Now, if I so for all kinds of unicast addresses, it performs DAD irrespective of whether it is like linked local or it is a unique local, which is equivalent to the private IPv4 addresses, or global. It performs duplicate address detection for all kinds of unique cast IP. This is what you can see in the RFC 2462 as well. Okay, so duplicate address detection, regardless of whether they are obtained through stateful, stateless, stateful, or manual configuration. So all the three methods which I just talked about, irrespective of how the host is getting the IPv6 address, it is going to perform duplicate address detection to ensure that the IPv6 it's going to use is unique. Now, let's go back. So how it performs this duplicate address mechanism, let's try to understand that. Okay, let me draw a simple network. Here you have PC1. This is connected, let's say this is a switch. This is connected to another PC, PC2. And we have one more PC in the network, just PC3. And let's say we try to assign one IP to PC1, which is, I'm using unique local IPv6 address, for example, FT01 colon 2222 colon 2222 colon 1 colon, let's say 1/64. This is the unique, this is the IPv6 address which I assigned to, let's say, PC1. Now, let's say this PC2 also has the same first 64 bits, and in the end, it's ::2/64, and this is ::3/64. Now, the moment I assign this IPv6 address to PC1, before it really acquires this IPv6 address, it's going to perform what we just discussed, duplicate address detection. To ensure that this IP is unique, nobody else in the network, PC2, PC3, none of them are using this IPv6 address. So it begins the duplicate address detection mechanism. So for that, the very first packet that it's going to send, let me change the color a bit, is the NS, neighbor solicitation packet. The important thing to note here is the source IP. What would be the source IP in this neighbor solicitation packet? It won't be this IP, because this, although you have configured it, it has not yet this IP has not yet been assigned to the host, because it wants to verify that this is unique. So it doesn't. It's like it doesn't have the IP right now. So the source in this neighbor solicitation message, which is being used for the duplicate address detection, would be unspecified address, which would be all 0. Oh, sorry. It should be all 0. This would be the source. Now, the destination IPv6 in this would be the solicited node multicast IP, which will be generated from this particular IPv6, which it wants to verify, for which it wants to verify the uniqueness. Now, I have already discussed how we generate the solicited node multicast IP in one of my previous videos, where I talked about neighbor discovery protocol on IPv6. You can go and have a look at that video. I'll put the link in the description. So the solicited node multicast IP would be generated, which would look like this. This is the standard prefix what we take, which is FF02 : :1 : FF, and last 24 bits we will take from the IPv6 address, which would in this case would be would be 1. Okay, so this would look like 1. Okay, so this is the solicited node multicast IP what we have got. So this will be the destination IP in the neighbor solicitation message. Now, let me do one thing. Let me try to erase a couple of things here. So once we have this, once host 1 sends this neighbor solicitation packet, because it is a multicast packet destined to the solicited node multicast IPv6, this packet would be received by all those hosts which have subscribed to that solicited node multicast IP. Now, in this case, basically all those hosts whose last 24 bit would match the last 24 bits of this guy here. Of course, it won't be PC2, it won't be PC3 in this case, because they have : ::1, : :3, which is different from 1. Okay. So in this case, it will not get the reply from anyone, and hence it can understand that this is a unique IP, and it can actually use this IPv6 address. But let's say if you let's say by chance this guy already had this IPv6 address, PC2. This IPv6, let's say it was matching PC1's IPv6 address. Sorry, PC1's IPv6 address. In that case, the moment it receives the solicited node multicast, the neighbor solicitation message with the solid-state node multicast IPv6 as the destination IP, it would actually respond to that neighbor solicitation message, because this PC2 would have subscribed to that solid-state node multicast IPv6 because it has last 24 bits, same as this guy. So, okay, I think my bad. So it will not respond straight away. It will receive the packet, it will open up the packet, and then it will see what is the target IPv6. The target IPv6 needs to match. Now, the target IPv6 would be this. In the neighbor solicitation message, I'm going to show you in the demo as well. Now, this guy will have the same IPv6 address as PC1. It will see that this IPv6 address matches the target IPv6 address in the neighbor solicitation message, which it has just received. And hence, it will reply with neighbor advertisement message. The moment it replies with the neighbor advertisement message, and the moment PC1 receives this message, it understands that somebody in the network has this exact same IPv6 which I was supposed to use, and hence it does not use this. It cannot use this IPv6 address. So that's the principle behind duplicate address detection. So now let's see what happens if we end up in a scenario where PC detects that the IPv6 address which it was about to use has already been configured somewhere in the network. What happens in that case? Let me tell you it. So if the IPv6 address was manually configured, in that case, you have to reconfigure the IPv6 address. If the IPv6 address, let's say, was given to the host by a DHCP server, okay, in that case, the client, it would behave just like standard DHCP mechanism. It would send the DHCP decline message. Host would send the DHCP decline message to the DHCP servers saying that it can't use this IPv6 address. This already being used somewhere in the network. And if the address was, let's say if we face this issue in the link local address, which is generating the link local address using the EUI 64 mechanism, basically from the MAC address of the interface. In that case, the MAC address of the interface, from here, sorry, if it was generating this IPv6 address. And in that case, if it finds the conflict, then you have to basically disable the IP on that particular interface. First of all, it's highly unlikely that, IPv6 address using this mechanism on link local, the link local IPv6 address would be same. It's highly unlikely because MAC addresses are unique. And hence, the link local IPv6 address, which would be generated using the EUI 64 mechanism, should also be unique. But I'm not sure how that condition can happen, but the RFC 4862 does talk about this case. For example, if I open it here, this is the RFC. Yeah. So here it does say that, if link local address, which we are generating using with EUI 64, using the MAC address, if we find out that it's not unique, then you have to basically disable the IP operation. That's the workaround, because if you don't do that, it's a bigger problem that you have. duplicate MAC addresses in the network. So it's advisable to disable. Now, with that, let's go and have a look at the packets in the simulation, how duplicate address detection would work. So if let me start all the devices, and then let me go to PC1. PC2 and PC3 as well. Okay. Let me access all these PCs. And then on PC1, I'm going to configure unique local IPv6 address on ETH0. Address add, let's say FT01 colon 2 colon 1:1/64. Okay, let's say this is the address which I want to assign on ETH0. Once I have assigned this IPv6 address on PC1, let me do one thing. Let me try to assign. So ::1 is on PC1. I would assign, let's say on PC3, I would assign ::3. Okay. So if you see here, IP address, you would see on ETH0, you have this IPv6 address assigned. Now, what I'll do is I'll assign the same IPv6 address on PC2, and we will see that it will detect, PC2 will detect that this IPv6 address ::1 is already being used by PC1, and hence PC2 will end up not assigning this IPv6 address to itself. So to see the packets, let me go ahead and start the web capture. Start capture. Okay. And then if I go to PC2, what I have to do is I have to assign the exact same IPv6 address as PC1. Oops. This thing and go to PC2 and give it the same IPv6 address, and we should see duplicate address detection in action right now. So if I go to the packet capture and here, okay, these are the other, first two are the other IPv6 packets about which I can talk probably in some other videos. So this is the packet I'm interested in. So this packet, if you see, the source IP is unspecified IPv6 address, all zeros basically. The destination is the solicited node multicast IPv6 address, which has been generated from this target by taking last 24 bits of this target IPv6 address, which would be nothing but 1. Okay, so it has appended this in the standard prefix which we use to generate solicited node multicast IPv6. And you can see this neighbor solicitation message for duplicate address detection is being sent by, if I look at the Ethernet headers, the source is this guy, B28C, which would be the MAC address of PC2. If I see PC2, IP address 0, 0, B28C, you see here? Yeah, B28C source. So there's PC2, which is trying to verify this IPv6 address, which I just assigned on its interface. to see whether somebody else is already owning this IPv6 address. So now I have already shown the source IPv6 is unspecified, destination is also multicast. Now this would be received by all the hosts which would have subscribed to that destination IPv6 address. And then because host 1 sees that it has the same IPv6 address which is there in the target address, and then host 1 here, it replies with neighbor advertisement. This would be received by host 2 here. So solicited node.
Hello. It's fine. It's fine. Okay, anyway. Yeah. So this reply is coming from PC1. The MAC address, source MAC address is 4E4E. Let's see. Let's go to PC1. And if you see on PC1, MAC address 4E4E. So PC1 replies with neighbor advertisement. Here, the destination is all host, all node multicast IP, so it would be received by all the nodes, and host 2 would also receive it, and it will, because it has got the reply, it understands that somebody in the network is using the IPv6 address, and hence host 2 cannot use that IPv6 address. And if you see now on host 2, IP address, yeah. So on host 2, if you see, you will see this IPv6 address is here, but it is in DAD failed status, which means the duplicate address protection a failure, that somebody else is using this network. So although we have configured it, this IP won't be owned by PC2, rather it will be owned by PC1. So that's it for this video. Thank you so much.